All right, here we go. So lesson 1.1 is about functions. The first part of this lesson is going to be review of old stuff, and then we'll get into some new things. So review. A relation and a function are two things that are very closely related. So relation is basically when you have two things in math that have something in common. Okay, so the first thing that comes to mind is an ordered set of ordered pairs, so like x and y. That would be considered a relation because they have something in common. X helps to create the y value. A function would be a more specific kind of relation where you have all these things that are related to one another, like all these ordered pairs, but they work in a certain more like methodical way. So there's this fancy definition here of what a function is. But really, when you get down to it, a function is something where each input has only one output. And I'm sure you've heard this before because this is something that's usually covered in Algebra 1, but I'll show you examples of what that means. I did put a really specific definition here with lots of vocabulary words, because in Algebra 1 we learned that a function is each input has only one output. And now that we're in pre-calculus, we're going to kind of like step up our game, I guess, if you will. So instead of saying input, we would say something like independent variable, that just means x. Or we could say domain, which also means x. And then we're going to say something like, instead of output, we would say dependent variable, meaning the y value. Or range would be another way to say it, which also means the y value. So let's go start with these. All I want you to do here is tell me whether it's a relation or if it's more specifically a function. Okay, so I'm going to explain function one more time. Here's another way to think of it. If you go put $1.50 into a vending machine and you push the Pepsi button, and the machine gives you a Pepsi, and every single time you put money in and you push the Pepsi button, you should get a Pepsi, right? Well, if something is a function, then that's the case. If it was not a function, then when you put your money in and push the Pepsi button, you would get a Mountain Dew instead. So when you get different outputs, like a Pepsi or Mountain Dew, for the same input, like pushing the Pepsi button, that means that you don't have a function. Okay, so if you're looking at a function or set of relations, and you have an input of 2, like I put $2 in the machine, and out comes this 5, and then another time out comes a 3, then there's something wrong with your machine, right? In order to be a function, you should be putting something in and getting the same result every time. So this would be an example of something that is not a function. Not a function. And if it's not a function, we would still be able to call it a relation. And the reason it's not a function is because the input of 2 has more than one output. Okay. B, the area of a circle is a function of the radius. So is that a function? If I put a number in, which, quick review, area is found by pi times radius squared. Okay. Not that you need to know that, but it'll be helpful to have a specific value here. So if I input a radius value into my area function, I'm going to get an answer that equals the area, right? If I put a number in for r, there's no possible way for me to get 2 different answers, right? This is a calculation. So that means that since every input would have its own specific answer, that is a function. Okay, last one here. Let me scroll down. This says, this is a table. So we have friends and we have their birthday, or people's names and their birthday. So if this is a function, that means every time you look at a name, there's only one output, which is the case, because if it was not a function, that would mean like Andy has 2 different birthdays, which would be cool, but it's also not possible. So this one is a function because each person has only one birthday. A few more examples. To try, if you're feeling confident, pause the video and give these a try on your own. If not, stick with me. So, is this table a function or a relation? Does each input give only one output? So the input of -2 is giving 2 outputs. Up here, it's giving an output of 8, and then down here, it's giving an output of 6. That's not consistent, so that would not be a function. We would just categorize it as a relation. This mapping, does each x go to only one y value? Yes, it does. So this one would be considered a function. Does anybody remember how to tell if a graph is a relation or a function? There's this thing called, I'm sure you remember this, the vertical line test. Vertical line test, where you draw a vertical line and you're checking to see if that vertical line crosses your graph more than once, which if you drag this along, it appears that it's only crossing the graph at one point at a time. So that would be considered a function. Now, let me do something real quick. It's not going to let me. Okay, I'll go over here. I'm going to draw one more example. So let's say I had that same parabola, but I rotated it 90 degrees. So now it looks like this. Would that one be a function? Let me grab my vertical line. If I bring this over, how many times am I crossing? My graph, I'm crossing twice. And if that is the case, that means that you have 2 outputs for that input value. So that one is not a function. Okay, so we would say not a function. And remember, if it's not a function, it's still considered to be a relation. Okay, so we'd call that a relation. All right, now we're going to get into function notation. So some of this is going to be familiar and some of it is not. We are going to kind of graduate from middle school vocabulary and move on to pre-calculus. So you can copy down everything you see here, but I'm going to summarize it like this. When you were in middle school, and even Algebra 1, and maybe even Algebra 2, you would see equations written like y equals whatever. What we're going to be doing now is we're going to be changing this to function notation. So function notation is where you're going to take y and you're going to instead call it f of x. And f of x is just another way of describing your function. So f means function, and the letter in parentheses is just saying what variable is being used to describe that function.